So, colleagues, welcome to those who've joined us online, and welcome to a really nice full room as well for this seminar. This is an IAS visiting fellow seminar, and we are very, very happy to have Glenn Dutcher visiting us, who has been here and has been such a popular fellow that while you were here last week and you were meeting all the colleagues who were here for the Breathe theme meeting, they were terribly disappointed when they realized you were not also joining them for their theme. And they said, but we thought he was great. He needs to be in our theme. So you are not only hosted by my colleague Anna-Rita Benato, but you have effectively been adopted by a whole host of other international visiting fellows over the course of the last few weeks. So we have been very, very delighted to have you here with us. It has been very exciting, and we're really looking forward to what it is you're going to be talking about. I'm going to turn to Anna-Rita to introduce you more directly, and then we're going to start the seminar in earnest. Welcome.
Perfect.
Thank you very much for this introduction. And let me also thank you for being so kind to help me to ask Glenn, which has been a great pleasure. So Glenn is an associate professor at Ohio University in the US, and currently spending also his sabbatical at Lyon at the Gate Lab. So his expertise is really wide, and I would say, applied micro theory in reducing behavioral economics broadly. So it's a great pleasure to have you here, Glenn, and we're very glad from your presence. Everyone has enjoyed, not to mention also junior scholars, from juniors to seniors. All right, so the time is shrinking, so I give you the floor, is all yours.
Okay, thanks both. Yeah, and thanks for the invitation. I mean, it's been such a nice it's already the end of 2 weeks. It's been such a nice and a really short 2 weeks. The weather has cooperated okay. I mean, a little bit of rain here and there, but that's what that's what you expect. But it's really been lovely. So yeah, thanks for this invite. It's such a nice opportunity to interact in these kind of interdisciplinary ways. And yeah, too bad I didn't have a chance to do more with the Breathe folks. That's But okay, let's get started, because I have already prepared 35 slides, and I'm risk averse. I want to make sure you get your money's worth. So there's no way we'll make sure we use up the entire time. There's no fear of that. This is a project that we've been working on for a little while now, and it takes a long time to get this data from the surgeons, and so it's ongoing. We're still collecting data on it. We have some preliminary things that we think are interesting, and so that's what we're kind of looking forward to, is seeing what you all think, giving you a flavor for what we're doing, why we're doing it, just to kind of spur some ideas. Okay, so this is a joint work with Ellie at Arizona State University. She's also an economist. With Jesse Schold he used to be at Cleveland Clinic. Now he's at University of Colorado School of Medicine. Jesse's a statistician. Also with Darren Stewart. Darren is currently at NYU Langone, but he used to be at UNOS, the United Network for Organ Sharing. So everybody, all of a sudden this last year, our other two co-authors moved. Jesse and Aaron, both of them are statisticians. They work in the transplant community a lot. This is my first foray into medicine, into health econ, into the transplant community. So it's been a lot of fun. And we have to mention, we're grateful for the funding that we received for the project from ASU, from the Arizona State University Jumpstart Grant, and also from the NIH grant number, whatever. Okay, so let's get started. The motivation here. We're really thinking about kidneys and improving the quality of life of individuals who have end-stage renal disease. So let's sort of talk about that a little bit. So in the US, 15% of the population has chronic kidney disease, and chronic kidney disease varies in the stages in the severity. Stage 5, by the time you reach stage 5, you have kidney failure, and that's when your kidneys don't work anymore. I looked up a little bit of some stats in the UK as well. So it's a big problem in the UK as well. Roughly 18% of the population in the UK has chronic kidney disease. I couldn't find the percentage that has kidney failure. In the US, roughly 20% of our Medicare dollars are spent on the kidney disease. In the UK, it's something like 1.4 billion British pounds each year that are spent on this. So economically, it's a big, it's sucking up a lot of resources. So whenever someone experiences end-stage renal disease, their kidney fails, there's two treatment options for them. One is dialysis and one is transplantation. So let's think about dialysis first. So what does dialysis do? So dialysis is this artificial kidney. So what dialysis does is it takes the place of the kidney. The most common form of dialysis in the US, 88% in the US, are going to a center, a dialysis center. What's involved with the dialysis center? So somewhere around three sessions per week, they go in and they have this artificial kidney cleaning their blood for them. And the sessions last anywhere between 3 and 5 hours per session. Okay, so what do we observe from dialysis? Well, first of all, there's a lower quality of life resulting from dialysis. Because relative to transplantation, because I mean, think about it, your kidney can't function properly, and you've got to wait, 3 sessions a week, you've got to wait 2 to 3 days before your blood is cleaned. That's not really healthy. It results in increased hypertension, increased problems with your cardiac system, etc. Patients that are on dialysis, their health declines rather quickly. It's not actually great for your health because of these reasons. The caveat, of course, is that, yeah, absolutely, dialysis is necessary. Without dialysis, 1 to 2 weeks life expectancy. I mean, you cannot live without your blood being clean. So absolutely, it's an improvement over not having dialysis, but there's a lot of downsides to dialysis. So the alternative to this is transplantation, and it's generally considered a preferred treatment. You have a better quality of life long-term with transplantation. You have a lower risk of death if you've received a transplant. You have lower treatment costs. So thinking about the monetary side of this, the treatment costs are a lot less with transplantation relative to dialysis. And so this is generally the preferred option. And within the US, roughly 72% of the transplants are coming from deceased donor kidneys. So a deceased donor kidney. So whenever someone passes away in the US, they talk to the family members and they ask them, would you like for your loved one to have their organs donated? And if they say yes, then the OPO, the Organ Procurement Organization, then we'll start running the tests on which organs they think can be transplanted, which ones might be suitable, and all of those kinds of things. So in the US, 72% of these of the transplants are from deceased donor kidneys. The other option is live donors, right? You might have a loved one, you might have someone that's close to you. If you have kidney failure, you can get a live donor transplant. With kidneys, you have 2 of them, but you can function with just one. The one that's left over just enlarges to take over kind of the place of the 2. But there's a major shortage in the US of kidneys. The number of people that are in need of a kidney transplant, the wait list is massive, and it's growing. Roughly 8% every year, the wait list is growing. But about 20% of the kidneys that are deemed usable are discarded. So we have a need for it, but we're also discarding ones that are usable. So the question that we wanted to address is why? So let's kind of think about what that process looks like. So let's say that you're a surgeon or a nephrologist, a doctor that has someone who is on the wait list to get a transplant. So if you're on the wait list, let's say that you receive the offer, so a kidney becomes available, you receive an offer. You then decide, do you want to accept this offer or reject the offer? And that decision is repeated for every patient until the surgeon either accepts an offer for that patient or that patient is removed from the wait list. And they might be removed from the wait list because they pass away, because they died, or they might just be removed from the wait list because they're too unhealthy to receive a transplant. Remember, the health declines, and this transplantation, this operation it's not minor, it's somewhat of a major operation. So they have to be healthy enough. In the US, we have roughly 10,000 people every year that are removed from the wait list because they're too unhealthy or because they pass away on the wait list. So why might they reject? Well, every offer is going to be different, and there's going to be a risk involved in these offers. The common metric that's used in the US is called the KDPI, the Kidney Donor Profile Index. The Kidney Donor Profile Index is just simply a measure that gives a relative risk-adjusted metric for that particular offer. So let's say, for instance, that we have a KDPI of 55. A KDPI of 55 says that on average, 55% of other kidneys will last longer than the one being offered. 80, a KDPI of 80 would say, on average, 80% of the kidneys being offered during the last year would perform better than the one that's being offered, would last longer. So as the KDPI goes up, then the risk of this kidney failure after transplant also goes up. So this is a common metric that's used in the US. So each time a surgeon or a nephrologist, sometimes it's a nephrologist that's at this decision, each time they reject an offer, the patient health declines. Because they're remaining on dialysis. Usually, there's not a lot of preemptive prior to dialysis. There's not a lot of preemptive transplants. But as they decline, the probability that a better offer occurs, or the problem is increasing, and the frequency of the offers also increases. So you might decline. Why might you decline? Because you think there's going to be something better in the future that it might be more suitable for your patient. So as those rejections build up, so as surgeons start rejecting more and more of these offers, the cold ischemia time is the determination for how long an organ can last outside of the body. The cold ischemia time builds up, and at some point we have to discard it. We can't keep kidneys outside of the body forever. So at some point we have to discard it. And so that high discard rate is really centered on these surgeons or these nephrologists' decisions to reject the organs in the hopes that they can get something better for their patient at some point in the future. So how can we think about then decreasing this discard rate? The primary mechanism that we think about, and the one that's most often argued, is that we need to change the way that these organs are allocated. So how are they normally allocated? Right now, the system is what's called a first come, first serve. That is, whoever is on the wait list first, they're the ones that have priority. So if you've been, you're right, and there's a lot of reasons why they think that this is maybe a preferred mechanism. I think about it. If you're at the grocery store and you're standing in a queue, that's in the US it would be a line. So I'm trying to a queue. So you're standing in a queue, and someone jumps ahead of you. It feels a bit unfair. Why should they get the priority over you to get their groceries checked out before you? No, right? I mean, this idea of this first come, first serve is oftentimes built around the notion that it's more fair. The alternative mechanism, the one that's sometimes argued, is what's called the last come, first serve mechanism. Last come, first serve mechanism means that the last person that arrives gets more priority points, is the one that has more priority. And the argument is that maybe we want to use this because it disincentivizes this rejection because you get something better in the future. So the argument is that this is going to be the preferred, maybe we want to move to something like this. But how do you get around that fairness argument? And in addition, all of the estimates on why that might be a better mechanism are premised on this notion that the surgeons are acting or the nephrologists are acting in the same way, that they're maximizing their patients' benefits in exactly the same way, that they're all homogeneous, that they're responding in exactly the same way. But we don't actually know if that's true. We've never actually talked to the doctors, the surgeons, to ask them, how are you making your decisions? Are you actually making decisions that are in line with how economists think that they're making decisions? That is, are they actually serving as what we call perfect agents in maximizing their patients' well-being? It could be the case, for instance, that these agents, these surgeons or nephrologists, are using some kind of decision heuristic. If they're using some kind of simpler decision heuristic, and I'll show you why that might be the case in just a minute, then their decisions are going to be different. And the implementation of some alternative mechanism might fail miserably because it's also working on the assumption that these kinds of things these decision heuristics aren't being used. In addition to that, changing an entire changing this entire allocation mechanism is really costly. You might engage in all of this costly change, or you're going to train the surgeons, you've got to make sure the patients are trained, all of these things. You might do all of that, and if they're using these simple decision heuristics, it might be for naught. And so we first need to sort of think about, right, sort of some of the first questions are those surgeons, are those doctors acting in the way we think they are? Are they acting in a homogeneous manner? So that's kind of what we want to do. The first thing that we want to do is just simply study whether or not these surgeons and nephrologists are consistent in their decisions after we control for a lot of other characteristics, like what center are they coming from? What kinds of patients do they have? What kind of donor is it that they're receiving the offer from, et cetera, et cetera. And in order to do so, we're going to use sort of this new and unique data set that we're putting together that looks at individual administrative data. And this is the part that's taking us a lot. This is 2 years in the making to just get so far about 50 observations. So we're getting a lot more on board now, but boy, does it take a long time to get these surgeons on board. And we'll go into that in just a minute. Okay. So let's kind of look at how economists think about this problem. I don't want to spend a long time on this, but I do want to kind of highlight how economists think about this, because I think it's illuminating to whether or not we think surgeons are following this methodology. So economists are modeling this process as an optimal stopping problem. And an optimal stopping problem would say, you know, at some point, I'm going to continue doing a thing. So I'm going to continue rejecting these organs up until some point where it's optimal for me to stop. I'm going to stop, I'm going to accept and transplant at some point. So what are the components that are needed in these optimal stopping problems? Well, the first thing that I need to know is I need to know kind of what is the value of the health for the individual on dialysis. And so, you know, we can kind of look at some of those things. Oh, because it's the screen. That's the bottom part here. The bottom part here is kind of how we can think about what is the value for rejecting, for continuing on dialysis. We're calling it waiting, for continuing waiting. And there's a couple of components here. The first is that, well, what is the health of the individual? What is their health? And the second is, well, what do I think is going to happen in the future? I've got to have a good projection of what do I think the offers are in the future, and what do I think the health of my patient will be if I'm going to accept some of those offers in the future. And so you model this thing as health is declining according to some process. And so what might be the benefit of this thing? Well, the benefit would be this top term. It's the value that the individual places on getting the transplant. Usually we're going to make an assumption that their quality of life is going to be better. So we can add some kind of constant reward component to that value, to sort of what their health is. But the important thing that we want to kind of take away from here is what are all of the pieces of information that we think the surgeons might need or the nephrologists might need whenever they're making their decisions. They need to know what the value of life is for their patients. They need to know, right, and they need to have some metric of that. They need to know what the probabilities of all of these various events look like, and they need to be able to calculate those things. So how do they do that? Well, the assumption, right, to solve these things is we start from the end. What might be the last period? So the very last period, right, the period where I think that, you know, if I reject at this point, then my patient is going to be removed from the wait list, they'll be too unhealthy. So is there some final period that the surgeons kind of know about? And let's say that there is, let's say that they know that. Well, this is kind of the problem that they're facing, right? So I'm going to solve that last period. And this is, right, we don't need to go over all of the components here, but you can see it. I mean, it starts getting a little bit messy. So once I solve that last period, then via backward induction, I can figure out what the optimal solution is in that last period. Then I can go to the next to last period. So what does the next to last period look like? Well, something like this, right? Okay, and then right, and then you keep iterating like this until you get to the current period. So you can see that the problem balloons pretty quickly. And so, right, I mean, fine. We don't have to say that the surgeons are necessarily optimizing in exactly this way, but the question is whether or not they're acting as if they are optimizing this way. And I think already, I mean, we should have some questions about that. I mean, there's a lot of information that they have to have. there's a lot of things that they have to get right in order for them to even act as if they are, optimizing according to this problem. So I think that should introduce already some notions, some questions in our mind about whether surgeons are actually acting in exactly the same way. There's a lot of instances where we might have heterogeneity here in how surgeons believe, what surgeons' beliefs are and how their decisions are made. So what do we do then? What I'm going to focus on today are these two pieces of information that are circled. The first is the data that we're getting from the transplant centers. And so the transplant centers, so we work with individual transplant centers, and we work with the center directors there, and the center directors then send out the note to their team, either nephrologist or surgeon. Hey, we're engaging in the study. We think it might be a good idea if you want, can you participate in this study? So what we get from the transplant centers is on-call data. So we know which surgeons are on call and when they're on call. We also get sort of their contact information so we can send them surveys and these sorts of things. So we're going to get all of that on-call data, and we're going to merge it with another data set. And this data set is coming from, it's the SRTR data set. The SRTR data set is center-specific data, and it has all of the decisions, every single organ that's sent out, every offer that's made, and what the decision is. Was it rejected? Was it accepted? That's what our focus is. And lots and lots and lots of other information, right? This is used by health professionals. There's something like 500-600 variables describing what the donor characteristics are. So the data set is pretty big. And we also know what the potential candidate characteristics are from this. So we're going to look at when an offer was rejected or accepted, when an offer was made, and we're going to match that up with which surgeon was on call when that offer was made. And so this is important here. Usually the way that it works is you might have an on-call, right? So let's say the center has, 9 surgeons. They're not always on, not all of them are always on call. One surgeon is on call at a time. And that one surgeon is the one who's going to be usually, we're enrolling another center now where it's not quite like this, but usually the one surgeon is the one who makes the decision. If an offer comes in for a patient at that transplant center, they're the ones that accept or reject that. They might not know who the patient is. They may have never met the patient. That patient might have been on the wait list for 5 years, and they really, they don't have any idea who the patient was. But they're the ones that are responsible for accepting or rejecting all of the offers that come in during that on-call period. And that on-call period is going to rotate, right? Week 1 is surgeon A, week 2 is surgeon B, week 3 is surgeon C. Oh, surgeon D is on vacation. Okay, we start back over again. Week 4 is surgeon A again, right? So it's sort of this rotation that most of them go through whenever they're assigned. And so we're going to take that information from the transplant centers and merge it with the SRTR. We might have some time to go into some of the other tasks that we're asking from the surgeons. They're filling out these survey mechanisms. So if we have time, then we'll talk about that. But for now, let's ignore it. Let's say that we usually use this data set. Oh, good. So we can skip one, right? Because I already explained all of this. This is the SRTR data set that we're getting, and this is kind of the information that it has. So let's think about then kind of the summary stats. So far, what do we have? We have 13 participating centers. We've got another 4 on board, and so we promised NIH we would have 18, so we're getting close. Which is good. Our grant is about to end. So we're getting close to the 18. So far, we have the on-call records for 9 centers. We have another 3 that they should be coming any day. I was really hoping we would get that before the presentation. We didn't, but we have 9 centers in this data set. We have 52 consenting participants, and that's participants who say, yes, I consent for you to use my data. But because we don't have all of the on-call records for them, we can't use. They said, well, you can use our data, but we don't have it. We don't have it yet. We have 23 participants who have completed everything, including the surveys. The observations that we're going to be working with today will have 38 observations. That's 38 individuals whom we have on-call data for that we've matched up to the SRTR data set. But at any point, it should be the case that we have We should reach that 50, the magic, we're hoping for at least 50, we'll reach the magic 50 number, hopefully any day. So the number of offers that we're analyzing in this data set is 326,000. Number of recipients, potential recipients is about 14,000. Number of donors, 7,000, about 7,000 donors. The number of offers that were accepted in our data set, about 3,400. At the doctor level, and whenever I'm saying doctor, I'm talking about nephrologists and surgeons. So the mean number of offers that they received. So sorry, another thing I forgot to mention. We're looking at their acceptance rates over a 4-year time period. So we're looking from 2016 to 2020. We're stopping at 2020 because of COVID. COVID kind of messed up this allocation. A lot of the, this isn't viewed as necessarily an elective surgery, but a lot of patients can live without dialysis. So it was kind of the space in the operating room was kind of taken up. So anyway, there's a lot of things with COVID that come with it. So we're stopping at 2020 with our observational data. So this is over 4 years. And we're starting at 2016 because there was a change in the policies of UNOS on how they allocate these mechanisms. And it was implemented starting in 2016. So we don't want to look at prior to 2016 either. Okay, so number of offers on average, 23,000. Minimum number of offers 188. There's one person who's a relatively new surgeon. Maximum number of offers over those 4 years is 37,000. So 37,000 offers over 4 years. That's a lot of decisions, right?
So per surgeon, 37.
Per surgeon, yeah. One surgeon made 37,000 decisions over the previous 4 years. We can talk about those problems too later. That's not efficient for one surgeon to be making 37,000 decisions. Number of patients range between 139 and 3,148, and this is per surgeon. And so that's essentially kind of, while that surgeon was on call, how many patients did they have in the center? Number of accepted offers per surgeon ranges between 1, so that's for the person who received 188, and 324. So one surgeon has accepted 324 offers. Their transplant team has transplanted 324. So that's the highest. Number of unique offers. So this is, and we can talk about this a little bit, but as you get an offer for one of your patients in your transplant center and you reject it, well, then it might be the case that that same organ is offered to another one of your patients in the transplant center. And if you reject it, it might be right, so forth and so on. So the number of unique offers per doctor ranges from 6 to 964. So KDPI, remember KDPI is this metric that we're using to measure risk. The average KDPI of all of the offers being made is about 64. So that means that on average, the offers that the surgeons and the nephrologists are seeing are on average about 64% of the alternative offers are better than the one that they're receiving. This is skewed a little bit because they're receiving multiple offers. I'm just looking at the average here. They're receiving multiple offers from the same donor sometimes. And remember, the higher risk ones, higher KDP offers are more likely to be rejected. So this is on the high side. It should be 50, right? On average, it should be 50. What else? Years experience. So we have different years experience, right? Some of them have been out for 2.5 years. Some of them have been practicing for about 30 years. Okay, center level characteristics. Let's think about that. We tried to get a pretty good spread within the US of geographic dispersion. So we have 3 centers from the Northeast, 3 centers from the West, 1 from the Southeast. We have a couple more coming online soon, and 4 from the Midwest. The centers are also going to vary in the aggressiveness. And I'll show you that in just a minute, what that kind of looks like. And we did that specifically. We wanted to choose centers where they weren't, we didn't want to choose only centers that were very aggressive. And whenever I say aggressive, I'm saying that they're more likely to accept high risk organs, right? We didn't want only high risk centers. We also didn't want only centers that were only low. We wanted to kind of mix that up a little bit too. The size of the team that we're analyzing also varies. Some of them have only 3 surgeons or nephrologists. One center has 9. That's the one center that has 9 is the one that's only nephrologists. We can't do more, we can't do fewer than 3 because for data reasons. You don't want to be able to identify the individual surgeons that are making the choices in the data. And so 3 seems to be enough where you can't do that. So we restricted ourselves to 3. For sure, we had some chances to survey centers that only had 1, but there's no way we can do that. We can't do that. I already said one of the centers we have has only nephrologists making decisions. The rest of them, surgeons are making decisions. And that's more common. Usually it's the surgeons that are making the decisions on acceptance or rejection. The average KDPI for all of the centers ranges between 0.53 and 0.67. Average sequence number. So sequence number is that wait list number. So if you're really high on the wait list, your sequence number is 1, right? That means if a kidney becomes available and it's a good biological match for you as a patient, then you're ranked number 1. You get the first offer, right? And so sequence number kind of tells us, a lot of things. How risky, how long have the patients been on the wait list? How risky is it? Pediatric cases get higher priority. If you're in the same geographic area, you get higher priority. Because we don't want to increase that transplant of these organs. As we increase the transplant time, cold ischemia time increases, and as cold ischemia time increases, the chance that graft is going to fail once transplanted also increases. So there's also been this push to limit the geographic area of transplant. Okay, so average sequence number of the patients. Ranges from 539 to 2175. So we feel like we have a pretty good range of centers that we're pulling from, which was the goal. And let's sort of look at, so the next picture I'm going to show you is 2 things. It's going to show you kind of what those centers look like in their aggressiveness, and it's going to show you also whether or not the surgeons within these centers vary in the decisions that they're making. So this is going to be kind of our first evidence for this. So these are the 9 centers. If you look at the bottom, this is the center number. So centers numbers 1 through 9. In parentheses is the number of observations that we have from each center. And on so that's on the horizontal axes. On the vertical axes, we have the O to E ratio. So the O to E ratio is a single metric for every surgeon. And it's just simply the number of offers they accepted, so that would be observed, over the number of offers they would have expected to accept. So this is a metric that's calculated for every single offer that's made. There's a calculated probability based on the patient characteristics and the donor characteristics on whether or not we think this offer is going to be accepted. And so this would be the expected. Yeah.
Is it the same surgeon who transplants the kidney who accepted it, or less?
No, it doesn't have to be. No, so right. So it doesn't have to be. Sometimes it is, and so we've had some calls with some of the surgeons, and we call them. Oh, you're on call. They say, yeah, I'm in surgery right now. Can you call back, or they just go ahead and continue on. Oh, sure, yeah, I'll get the email to you. So sometimes the on-call surgeons do the transplant, but sometimes they don't. It's this rotation. Obviously, they're not going to do all of them, right? If you have 9 surgeons at a center and one of them is on call for a week, it's not the case that one surgeon is doing all of the transplants that they're accepting. No, yeah, they're accepting, and in most cases, it's the transplant team who is doing the surgery. Yeah.
You haven't mentioned capacity, or is there a capacity constraint about how many they can do at one time?
There is. Yeah, there is. It is. Yeah, that's right. So that's why we think that analyzing this data at the center level is, looking at if there's variation in the doctor's choices at the center level is probably the way to go, because we're going to control or hold constant a lot of those other things. But you're right. There's capacity constraints. There's all kinds of other things that are messy in this thing. Yeah, you're right. And I mean, adding more to this complication is not only is there a capacity constraint, but a lot of these surgeons aren't only doing kidney surgeries. They might be doing other surgeries as well. So then, often, almost always, if they're doing kidneys, they're also doing pancreas and probably liver. But in addition to that, it might be a general surgery center. Right. And so they might be doing other surgery. Maybe they're doing a knee surgery. I mean, probably not, but within that same transplant center, Yeah, within that same surgery center, which would be the transplant center, they might also be doing other kinds of surgeries. And so, right, controlling for those center level effects is kind of really important because there's a lot of other things that could come into play here. And one thing that we're looking to do now going forward is looking at why we think some of these centers are more aggressive than others. So this metric, this observed to expected, says that on average, if you have an observed to expected of 1, that means on average you're just like everybody else in the population. All of the other surgeons in the population would on average accept this. So the number of acceptances I have is roughly equal to the number of acceptances that we would expect on average. So 1 is kind of the baseline. If it's 2, for instance, then you're accepting twice the number of offers relative to the average, controlling for patient and donor characteristics. So as we I've highlighted a few things here. One is we chose the centers based on, now this is sort of an older metric. We chose the centers based on their historic O to E ratios, and that's given by the small red bar. The small red bar tells me kind of how aggressive those centers are. And this is kind of, looking at some centers are simply more aggressive than others. Some of them are accepting on average more offers than other centers. And so that's that little red bar. The blue is this box and whiskers. It's telling me a couple of things. It's telling me, in that blue box, the dark blue line is the mean for the surgeons that we've surveyed or that we have the on-call data for. And sort of the light blue area is the dispersion, is the variance of the O to E ratio for surgeons that are in that center. So we can already see from this that we have some centers that have pretty small variance, and we have some centers that are pretty big variance in this. So within a center, even controlling for all of those things, there's already some evidence that they're a little bit different, that some of these surgeons are making decisions differently, whereas some centers are pretty consistent. They're not really varying that much. So, what can we do then to sort of check these kinds of things? We're just going to use this logistic regression, right? This logistic regression model, this binary choice model. And we're going to do these for each one of the centers. So we're going to do a separate regression for each center. So for each of the centers, we're going to include as a right-hand side variable, it's a probability. So it's an SRTR calculation of the probability that this offer is accepted. Now, the reason why we like this for every single offer is because that probability is calculating the donor and the patient characteristics. So it's essentially giving us a really nice control in one variable for controlling for the patient and donor characteristics from the offer. At some point, what we're trying to do now is we're trying to disaggregate this, and we're trying to look at individual components, but that'll be down the line a little bit. But for now, we're assuming that, all of the epidemiologists that have been working on this for the last 20 years are, we'll take their word for it. This is pretty accurate. And so as a starting point, I think it's an okay assumption. In addition to that, we're going to include binary variables for each surgeon in the center. And so what this is going to do is it's going to allow us to do pairwise comparisons of the surgeons to say whether or not surgeon A within the center is different than surgeon B. We can do, so we'll run this where it's a random effects model. What else do we need? Yeah, we'll cluster the errors at the surgeon level as well. Okay, so the base model is just this very traditional logit regression. We're trying to control for stuff. We're trying to make sure everything is clean at the center level. Okay, so right, the proposition, all else equal, surgeons are going to be the same, are they? Well, we already saw a little bit from that first graph that we might expect some differences. And so if we do these pairwise comparisons, center by center level, some centers are more consistent than others. Some centers are really different, right? Look at the centers 1 and 2. For the 3 surgeons that are at the first 2 centers, all of them are different than each other. All of them are making different decisions. Their acceptance decisions are different than everybody else. But you have some centers like centers 6 and 7, where we aren't picking up any statistical difference in those two. So some centers are really consistent. We already saw in that first graph, some of them are the surgeons are a little bit different. So on average, it looks like, you know, we're getting, if you do these pairwise comparisons, something like 27 of those pairwise comparisons give us a difference, and about 46 are giving us consistent, that that within the center there's no difference. If you really want to think a little bit deeper, you would say, yeah, but maybe I really am concerned about high KDPI kidneys, those kidneys that are the ones that are going to be discarded. Okay, so you rerun this thing, and if you set your break off point at any kidney that's above 0.5, that's the median, right, of all of the offers. So on average, 50% of the kidneys that were offered will be better, will last longer than the current one. You don't really get that much of a change. It's still pretty consistent in how they're making these choices. So we have roughly over a third of the surgeons or the nephrologists' decisions are different. What does that translate to, right? If we condition the KDPI on acceptance, on average, the acceptance, the lowest KDPI, the average KDPI of the accepted organ is 0.38 all the way to 0.62. So we can imagine now, right, that we're seeing this variance, and we're seeing it directly translate into different kinds of acceptance levels. So the proposition then is, maybe we don't need to engage in completely changing the system altogether. Maybe we really need to understand the individual surgeons, why are individual surgeons making those choices? That might be it's certainly potentially much easier to implement from a policy perspective than changing the entire system. And so then what are then the next questions? The next questions would be, okay, they're different, but why? What kind of information do the surgeons and nephrologists have, and how are they using that information? And our focus, good, I still have 5 minutes. Our focus is really on a few things. So one is the quality of life of their patients. How do they differ in their perception of the quality of life of their patients? Because that could obviously matter. For instance, if they think that their patient is just fine on dialysis, if they think that the quality of life of their patient is really high on dialysis, they would say, well, maybe I don't want to accept this organ. Why? Because, well, it's not so bad. What they have isn't so bad. Or if I think that the quality of life of my patient under transplant isn't really that good, maybe it's better, but maybe there's a lot of complications, and I don't know that my patient wants to go through that. If they think that's true, then that could also affect whether or not they're accepting or rejecting. And so we use a metric called the SF12. We didn't develop it, so we're taking it from others. This SF12 measure that's usually given to patients that measures the patient's quality of life. But we're asking the surgeons, what do you think the patient's quality of life will be over these domains? First, dialysis, they don't receive a transplant. Second, what if they transplant and they don't have any complications? Third, what if they have a transplant, but some complications? And fourth, what if they have a transplant, but the graft fails? There's a failure of the transplant. We're assuming in this case, there's a possibility of death, but the quality of life of a patient with death is 0, so we don't need to measure that. There is no quality of life there. So we have 2 measures there. One is their mental health and one is their physical health. And the SF12 kind of backs that out for us. The other thing that we need then, so we have one side of the equation, which is the quality of life that the surgeons believe the patients are experiencing under these different scenarios. We also need to understand what they think is the probability for their patients to have those different scenarios. So we're also, this is where the surgeons hate us. We're also eliciting from the surgeons what they believe is the probability of death, graft failure, graft function with significant complications, graft function with no complications. So what is the probability that their patient will experience these outcomes after 1 year post-transplant, 3 years post-transplant, 10 years post-transplant? for four different KDPI kidneys. KDPI of 95, which we would say is a very low quality organ, KDPI of 80, which is better, but still not very good, KDPI of 50, and KDPI of 10. So we're measuring their beliefs of probabilities and also then their beliefs of quality of life. And again, do we think they differ? If we map this out and we extrapolate and interpolate all of those fancy things that we can do with our regressions, we can map out then what they think probability of graft failure or death is. So each one of these colored lines represents one surgeon's beliefs. And then, so that's on that probability of graft failure is on that vertical axis. The horizontal axis is the KDPI. So as we, increase KDPI, decrease the quality of the organ, then we should expect upward trend, right? That probability of graft failure or death increase. And then generally, we usually see that. We usually see that. But what's kind of important here is that there's also a lot of variance. They differ in what they think the probability is of these various outcomes occurring. The second thing, of course, then is, well, what about is there also a difference in the quality of life that they believe their patients will experience for those various outcomes? And yeah, there is. They differ quite a bit on kind of what they believe is the quality of life of their patients under these different kinds of scenarios for both the physical, which is on the right side, and the mental aspect. Okay, so more graphs, more stuff, fun stuff. What's kind of the conclusions, right? I think where we're going with this thing is we really want to try and then map out. So we've got a good sense for do they differ or don't they differ? But I think then the next step is really mapping out and really trying to understand how they're using these beliefs, how they're using this kind of information. Because I think that's really the relevant piece of policy. The relevant piece of policy that would be easy to implement is if they have incorrect information, let's fix it. Let's see what's going on, right? But maybe they have the incorrect information and they don't really use it. Well then, if that's the case, I'm saying information according to the economics models, right? Information on probabilities or information on quality of life. But if they don't use that kind of information, then what do they use? What other things are they using in order to kind of make their decisions? And so that's kind of, yeah. So I think for the moment, right, I'm pretty convinced that they're different. The surgeons and the nephrologists are different. They're making different decisions. They have different kinds of information. The next step then is to kind of think about extending this into the future. How are they using that kind of information? Okay, good. So 3 minutes over.